Hey everyone, welcome back to Derive It, and in this video we're going to be talking about tree traversals. So right now I'm just having you look at one of the tree traversals we're going to learn about. And if you just stare at some node here, you're going to see that the node is going to light up, and then all of the children to the left of it will, and then all of the children to the right of it will, for literally any node that you pick. So we're going to go over this traversal in this video, and we're also going to go over all the other ones you have to know. So a tree traversal is just a function that visits every single node in a tree and does something at each node. So maybe we want to, do something would be add all these values to an array, or maybe it would be print them all out. That's up to you. Do something is whatever you want it to be. So we want a function that visits all the nodes and does something. And the function is given the root of the tree. So this is the function we want, and now we're going to try to write it recursively. So all that means is we want visit all to show up on both sides of an equation. So if we can do that, if we can get visit all on the left side of an equation, and also on the right side of an equation somehow, then we have a recursion and we can pretty much immediately code up the solution. Visit all is supposed to do something on every node in the tree. So we want to do something on the root, and then we also want to do something on all the left children. And then we want to do something on all the right children. So we pretty much just came up with the recursion. Visit all of root is kind of equal to doing something on the root, and then visiting all on the left child, and then visiting all on the right child. So this is the recursion we're going to use, and every recursion needs a base case. So when should we stop applying this recursion? So we're going to keep breaking down visit all of root into visit all of its children. So we're going to eventually reach a point where visit all gets called on the bottom of the tree, and then it's even going to get called on null. And when visit all gets called on null, notice that this recursion is going to break, because if we call visit all on null, then this recursion is going to try calling null.left, and that's going to give an error. So this recursion is valid until we reach null. So how do we do something on a null node? Well, we don't really even have to do anything because the node is null, it doesn't even exist. So visit all of null is just, don't do anything, return. So we have our recursion here, and we have our base case, and we can use those two things to completely code up the solution. So we want to create our function visit all, and visit all is equal to the recursion unless we're in the base case, so unless the node that we're calling it on is null, in which case visit all is equal to just doing nothing, returning. And so this is literally the code that will visit everything in the tree that we have and do something at each node. So just notice that the way we coded this up, do something always gets called before any of the children. So we're always going to do something on the parent, and then we're going to do something on all the left children, and then all the right children. So that's kind of the defining feature of this code here. We call do something on the current node, and then we call it on all the nodes in the left tree, and then all the nodes in the right tree. This kind of defines the recursion and the code that we just came up with.
So here's what happens when we run this traversal on a tree.
And you can see that literally every single node in this tree is first going to do something on itself, and then all its left children, and then all its right children. So just pick some node and stare at it, and you'll see that that node will turn red, and then all its left children will, and then all its right children will.
So this traversal is called a pre-order traversal because it first visits the current node pre all the other nodes, and then it visits all the nodes to the left and then all the nodes to the right. And so this view of current, left, and right is the view you should have with this pre-order traversal. There are a lot of other ways of looking at it, but they're not as useful as this view. And there are two other standard types of traversals you have to know about. And we kind of had the choice of putting do something over here, but we could have also put it between these two function calls or after them. And so we can get two other traversals if we do that. If you put do something in the middle, it's called an in-order traversal because we're first visiting all of the nodes to the left and doing something on all of them, and then we're doing something on the current node, and then we're doing something on all the nodes to the right. And so we're kind of doing things in order, hence the name. So this is an animation of an in-order traversal running on a tree. So just pick any node and stare at it, and you can see that do something will first get run on all the children nodes to the left, and then after that it'll run on the node you're staring at, and then it'll run on all the children nodes to the right. And so just try this out yourself, pick any node, and this should work. And the third type of traversal is when you put do something at the very end, in which case you're doing something on the current node post all the other nodes, or after all the other nodes. So it's called a post-order traversal. So this is the animation of a post-order traversal on a tree. If you pick any node and look at it, it's first going to run do something on all the nodes to the left, and then on all the nodes to the right, and then finally on the node you're looking at. And so this is useful when you want to do something on all the children nodes before you do something on the parent nodes. Okay, so these are the 3 standard types of traversals that you have to know about, and I recommend looking at them whenever you see their names. Just think of current, left, and right, and put them in the correct order. And I guarantee you, whenever you come across these traversals, this is the correct way of looking at them. These traversals are sometimes called depth-first traversals, or DFS, and that's because they just call themselves in the same exact way over and over again, which means that they're going to keep stepping deeper into the tree, and they're not going to step in layers. They're not going to visit nodes like this. If you want to visit nodes in layers, you have to do something different. You can't use recursion, and so we're going to talk about that in the next lesson. By the way, depth first search isn't really special. Literally all recursions are depth first. It's just the nature of recursion. They do the same thing over and over again. Okay, so that's genuinely everything you have to know about these types of traversals. They're really not more complicated than this. And hopefully I'll see you in some of the practice problems that we have on this.